So welcome back. We have just now seen the work kinetic energy theorem, which says work done by a force is equal to change in kinetic energy. So we will apply this work kinetic energy theorem in order to find expression for work done. Here is a situation which has been given. There is a spherical ball having a mass m and constant force F is applied to this sphere or to this ball, and which is making an angle phi with the horizontal. And consider this sphere is moving in a horizontal surface which is frictionless, and since a constant force F has been applied to this ball, its velocity would change. So initially its velocity is vi, and after traversing a distance of d, the final velocity of ball is vf. Definitely the final velocity would have changed because a constant force F has been applied to this spherical ball, and we need to find out an expression for work done, and we will utilize this work kinetic energy theorem to find out this expression. So we can begin with work done by this force F is change in kinetic energy, that we can write as half mv final square minus half m v initial square. So this is the final kinetic energy and this is the initial kinetic energy. Half m can be kept common and we have v final square minus v initial square. So this is the work done by the force F, and we need to find out the expression for this one. Okay, so let's start. So if we find the value of mass F is given, and if we find out the value of v final square minus v initial square, and we can put those values here and we can find out the value of work wf, that is work done by the force F. So how can we find out the value of v f square minus v initial square? Since a constant force F is being applied on the spherical ball, we can utilize the Newton's laws of motion. Since the force is constant and acceleration is constant, so we can use Newton's laws of motion. We can use this formula: v final square is equal to v initial square plus 2ax x minus x naught. We all know that it says v final square is equal to v initial square plus 2ax. Ax is the acceleration of the ball in x direction, and x minus x naught is the displacement of this ball in x direction. We have already considered the coordinates in this way, that the path of movement of this spherical ball is the x-axis. Okay, so we need to find out. Okay, and proceeding further, if we find out v final square minus v initial square from this expression, which is equal to 2ax x minus x naught, and we can directly put these values here and do our job. Okay, so we will find out this. So what is the acceleration in x direction? So since the force is acting on the spherical ball at an angle phi with the horizontal, acceleration in x direction will be equal to 2 into acceleration in x direction will be equal to force in x direction divided by mass and x minus x naught. Here we can see that x minus x naught has been given as d. This one x, this is the final x, this is the final position, and x naught is the initial position, and x minus x naught has been given as d here. So we can directly put the value of d is equal to 2 into fx md. Okay, now we can see what is the force in next direction. It is definitely f cos phi. So we can put the value here, f cos phi divided by m into d. Okay, so we have found out the value of v final square minus v initial square as this, in which f has been given, phi has been given, d has been given, and similarly m is given. So we can directly put this value in this equation. So we will get, let's come down a bit. Yeah. So here putting the value, we will get V work done by force is equal to 1 by 2 m. Now we are putting the value of V final square minus V initial square as this, and that comes out to be F cos phi into D divided by m. So m gets cancelled out, 2 gets cancelled out, and we finally come up with F cos phi into D. And as we all know that f is a vector quantity, and if cos x into d, we can say that f is a vector quantity and d is a vector quantity. And if we will do dot product of f dot d, that is equal to f dot product of d is equal to nothing but f cos phi into d. So we are simply replacing f cos phi into d with f dot d. So finally, the work done, we have got the expression for work done by this force. This says work done by the force F is nothing but dot product of F vector and D displacement vector. We will come up in this picture and see. So what is the force? Force work done by the force is equal to F vector, the force applied vector, dot D vector, which is the displacement vector. This is the final expression for work done. Okay, so we'll discuss further in the next lecture.